This is a video primarily about one, but is really a story about three plotters, each with average capabilities, but all leading to a product that was greater than the sum of its parts. The HP 7475A plotter. This is a pen plotter. It takes vector data from a computer and draws it onto a sheet of paper. The 7475 brought nothing new to the market when it was released, but what it did bring made it such a dominant force in its segment that it was the gold standard up until the end, and somewhat still now. Today, we're going to take a look at the history and impact, restoration, and the usage of the plotter that set the course for its industry, much like how the Epson MX80 and IBM PC also did. There really wasn't any one novel feature of the 7475A that made it so good. Its biggest selling point was holding 6 pens instead of 4, but there were plotters before it that could hold 8. Speed was always an improving metric, but it wasn't any faster than HP's own models released 6 years before it. The same can be said for its resolution as well, which was limited by its control language rather than its mechanical capabilities. But that language was actually one of the biggest aspects that made it have such a huge impact. This plotter uses HPGL, the simply named Hewlett-Packard graphics language. HPGL was first shipped with the HP 9872 in 1977. Here I have the 7221 sister product, which was nearly mechanically identical but did not use HPGL. But this is actually an interesting comparison. I've been struggling to find understandable documentation on how to program for this plotter due to its compact BCD interface protocol. HPGL, on the other hand, uses ASCII command lines with simple 2-letter statements to communicate. It's nearly instantly obvious how to use the plotter when looking at these commands. However, the 9872 plotter was relegated to usage with mostly HP computers because it used an HPIB interface. The 7221 here is the serial model, but without HPGL support, due to wanting to avoid the verbosity of plain ASCII commands over a potentially expensive time-shared mainframe connection. This was one of the things addressed by the HP 7470 in 1982, a plotter I've already taken a look at in its own video. It was available with HPGL and a serial model was made. HP was directly going after the IBM PC market with this plotter, trying to appeal to a broader audience. This was coupled with HP aggressively pushing software developers to add support for HPGL to their products. As you could surmise based on the name, there was no universal plotter interface standard, and each manufacturer was creating their own graphics interface protocols. The 7470 brought more than just a language gaining manufacturer support though. It simplified the design of the hardware significantly and made it much easier to use. Stationary electrostatic beds like on the previous plotter were replaced with a single pen axis and rollers that grip the paper to move it in the other. This reduced the overall size and weight of the machine due to much simpler mechanics. The 7470 was only a 2-pen plotter, though it was half the cost of the previous 4-pen $4,200 plotter coming in at $1,795 at introduction, and this would drop quickly. But for plotters, more pens is always better. Finally, the HP 7475 enters the scene in 1983. It brings with it the now well-supported HPGL interface of the 9872, the simpler mechanics of the 7470A, and adds a 6-pen carousel to bring it up to par with the bigger of its rivals. It also added support for both A and B-sized pages by rotating the bed layout and extending one of the rollers inwards more. All this for $1,895, with the 7470 also being discounted permanently to $1,095. The 7475 was reviewed well at launch, but it didn't have much to stand out with and was just perceived as an all-around solid device. One feature of all 3 HP models reviewers still enjoyed was the plotter's design to seal the tips of pens when being stored in the plotter to prevent them from drying out. Elsewise, you would have to remove all of them after every session just to put their caps back on. The 7475A sold well and was never actually replaced with another model. The 7470 was eventually replaced by the Color Pro, which gave it 8 pens, but did not add wide format paper support. This meant new software continued supporting the 7475 for years, and this is where it gets really interesting, because manufacturers of other plotters decided to take advantage of this and started providing HP emulation with their models, allowing them to use software with HPGL support for the 7475. Even non-vector devices like this AST laser printer would support HPGL, which as a raster device would have to handle it completely differently. HPGL became the de facto standard plotter interface protocol, and many implementations were specifically aimed at the 7475 since it brought so many common features together in one place. This support even continues today. Inkscape and KiCad are just two examples of programs that can still natively output HPGL as plain text files to be sent to plotters. This makes using it today still entirely possible with modern computers. But, being 40 years old, you're nearly guaranteed to run into some issues. I was sent my 7475 plotter in a big lot of HP hardware from James in Indiana. Being unfamiliar with the device, I decided it would be prudent to open it up before powering to inspect, and I'm quite glad I did. The very large power filter cap in it was leaking badly. Thankfully, it had not corroded anything though. Oddly, after I removed it, I found it had been seeping back up the jacket and crystallizing, which was a new failure mode to me. This cap obviously needed replaced, so I went ahead and spec'd out a near full cap replacement set on CapsWiki. I decided not to replace the small axial ones because they looked fine and new ones were outrageously expensive. The recap was mostly typical, except for the fact that the giant leaking cap technically doubled as a mechanical support. It has a socket with foam padding on top that supports the pen rail piece. It may not have been needed, but I thought this would be a fun time to try restuffing a capacitor with a smaller modern one. It was not easy, and I almost tore the case apart, but I was able to do it and got it back into place in the end. Again, this probably isn't needed, but I was trying to keep it as stock as I could and didn't know how removing it would affect it. After I knew it wouldn't catch fire, I was free to turn it on for the first time and was pleased to have it work flawlessly. I was alarmed by the brutish method that it uses to find the first pen in the carousel, which is done by slamming a peg up against a stock and checking the motor current, but it was working. Now that it was known to function, I started working on some better demonstration software on my new favorite HP system. But when I got to the point of testing it, that peg had sheared off of the pen selector gear. It turns out it's a softer plastic part, which makes this even less surprising. But I knew it was bound to happen anyway because Curious Mark, who also plays with copious amounts of HP hardware, had the same thing happen. He got some help with a replacement part for the gear with 3D printing and has posted the model online. So I did the same as him and printed a new part to put in. With that one in now, it's finally working perfectly and we can begin to test it. I've got a few different ways to do that I want to check out. So let's see what using one of these is like. Now, to demonstrate my 7475 here, I've connected it to my IBM 5160, and I've got a program called KiCad Complete that we're going to run on here, and this is a compatible program. Now, I thought this would be cool because this would be a much more representative way that most people probably would have used one of these. They would have got some software that supported the plotter and then used it with their PC. Unfortunately, I can't really easily do that. And the software is the letdown, but we'll get to that in a moment. We will demonstrate this thing in another way in a bit, but I just want to go over this really quick. So first, let's talk about setting up the plotter so that we can use it. Now, I want to start off with a simple demo to begin. So I'm going to take one of my pens and I'm going to put it into the carousel here. Then I can just drop that back down in, turn the plotter on, and it's ready to go. Now, it will have to home when I tell it to pick up the first pen, which is going to have it slam that peg into the rubber stopper again. Always horrifying, but now it's ready to plot. So I can take a sheet of paper here and I can slide this in here and drop this down. Now, minor note here, there is a paper stop back there that raises and lowers with the paper latch. And that's how you know mine is an earlier revision, 7475, because later on, they just put a white line right there due to a lawsuit. So minor fun fact there. Additionally, it's worth knowing that there was actual plotter paper available for these types of machines, but I'm not using that here because, well, if we look at my pens, you'll see this is T3. Maybe I get one that's a little darker here. T.3, that stands for transparency and then the tip width. I do actually have one single paper pen, but these pens are mostly supposed to be used on transparency sheets. So if they're going to be wrong, they might as well be wrong in a way that doesn't use up my limited number of plotter sheets. All right, once you have the paper locked in like that, you are ready to plot. You don't even have to tell it to grab a pen like that. The software should, and I think it will also just grab one if it knows it hasn't yet. So it's pretty smart with that. But with that, let's check out the software. Now I've closed the software so we can restart it and check it out here. The program I'm running is called KiCad. And no, not that KiCad. But while I'm doing an aside here, you may have noticed I'm running an IBM 5151 monochrome monitor. Now, it's important to note that I'm not running it with an MDA card. I actually have a Hercules card in here. That is probably the more likely option that you would use if you were going to use a PC for plotting at this time, because the Hercules card is actually going to be higher resolution than even the CGA card would be at this time. So you're going to get finer details to display on your screen. Now, you could just zoom in and pan around, but eliminating full screen redraws is very beneficial. So we're actually going to run this program in Hercules mode to demonstrate this. And that is done by simply adding a /h as a launch parameter. And there we are, SoftKey KiCad Complete version 6. Another side note, it's weird they call it version 6. I'm not even sure if there were any versions before version 6, because this is the only one I've ever seen available. Now let's go ahead and load an example CAD file. This comes with a bunch of them to just show you how this thing works. And we'll go ahead and load Batcar because, well, for one, it's smaller and will load quickly, and it's just hilarious. And there we are, the Batcar prototype, designed with KiCad 6.0. And this is what you get out of the CAD software. It's kind of cool. I haven't actually tried designing anything with it yet, but it's clearly functional. So let's go ahead and try plotting this. So I'm going to press F here, and we're going to go ahead and configure our output. So the device is set to an HP 7470 plotter. That's functionally compatible with the 7475. There's just more pens and a wider paper support. Doesn't necessarily have to use it. So we'll go ahead and select that. The output is going to be COM1. And I should mention this, as I stated, my 7475 is a GPIB plotter, but I'm actually using a National Instruments, I guess, GPIB to RS-232 adapter. And it does work, and it works really well. So that would allow me to send HPGL commands over serial, and then they get interpreted by the plotter. Again, there was a serial version of the plotter available, so that's a somewhat expected use case. I'm going to go to my baud settings. I have configured this to 9600 8N1 as my settings, and that all looks right. And with that, it should be set up. File, plot, print. It's saying it's going to be 7.5 by 10 inches. That sounds good to me. So we will go ahead. Oh yeah, we got to offset. That doesn't matter. You will see in the bottom left there, status is 0, and I've never had to go past that. I really don't know what it is about KiCad that is not working here, but every time I have tried to access either this plotter or my 7470 with it, it just fails, and it never actually progresses. For the longest time, I thought it was my setup, but I now have a way of demonstrating it isn't. So let's actually restart here. We're gonna have to Control-Alt-Delete, because even though it says I can press Escape, I can't. But let's Control-Alt-Delete, and we'll manually control the plotter for a moment. To do this, I'm going to CD to Kermit. This is a serial console program, so I'm going to run it here. And with this, I'll be able to send HPGL commands directly to the plotter. Now, there are a few things that we need to do to configure this. I'm going to set port to 1. I'm going to set speed to 9600. And there are some other things I don't remember. I'm going to set local to on, because the plotter adapter is not going to send me back my own characters. And I'm going to set term new line on. I'm not actually 100% sure what that does. In reality, I'm following the Kermit setup PDF, and that's just one of the demos that I happen to know works. But with all those set up, I can run connect. And now I am in a terminal that I can send data to the plotter with. All right, now to show you how simple this is to command here, I'm just going to do SP2 enter. Yeah, it's very dumb. That's its whole little charade it goes through to figure out if it has pens in all the spots. But that's how you can do pen changes. Now that it knows where all the pens are, SP1. We'll have it changed to pen 1 again. Now, I'm going to do pen absolute space 0, 0, enter. And there is position 0, 0 on the paper. So, what I can do is PD, pen down, and then I can do pen absolute. You know what? No. I'm going to enter. I'm going to do pen relative 100 X, and then say 50 Y. That was very, very small, okay? Let's do pen relative 2,500. There we go. Now I'm gonna do pen up, and I'm going to do pen absolute, let's say 2,000. No, yeah, 2,000, 1,000. So you can now see the area where it drew on the paper. You can also see the dots where it was staying when I was sending it commands. And keeping track of pen down and pen up while you're working with this is very important, because if you just leave the pen sitting on the paper, it'll slowly bleed the ink out of the pen, which is very annoying. I just noticed while doing all those commands that Kermit says it's running in 7N1. That's 7 data bits, N parity, or none parity, and 1 stop bit. I wonder if that's how I need to configure KiCad. I absolutely set this thing to 8 data bits, and I even tested that with Putty on the Windows XP computer over there. So I'm not sure why it would be 7 and working with 7, but maybe there's some weird quirk with this serial card, which I believe was my Tecmar Captain. So, I don't know, let's try KiCad one more time, just in case it works. So 9600, we'll leave it at N, and we're gonna set it to 7 data bits. So it's 7N1 now, okay, like Kermit was. And we'll save that. I don't know if saving actually does anything or not, but just in case. And I will go ahead and plot this, and we'll see what happens. And the same thing, status is 0%. I don't know what KiCad's problem is. It's not a very good program to begin with. I had another problem with it when I was trying to use a different video card where it was trying to drop into Hercules mode when it shouldn't, and the card couldn't even work with it. It was one of those switchable monocolor cards, and I think it was trying to write into the address space of an area for the card that it shouldn't be able to use, and then it was showing up anyway. So yeah, it's just not very great. But this isn't the only way that we can use this thing. So now I'm going to connect it to my HP Series 200, which is the environment that it's really meant for. And we're going to run a program on it that I wrote myself. I figured while getting it set up, I'd show you the HPIB port here that mine has. So we'll be connecting the pass-through connector on here like that. It's a very weird setup here. And these are the dip switches that control the HPIB address. If you had the serial version of this, these would control your baud rate settings. I have mine currently set to address 5, but for this, I'm going to change it to address 7 here, for reasons you'll see in a moment. This is the HP Series 200 setup we'll be using to take a look at this plotter. And this is basically the best computer that you could have used with that plotter at the time. So I'm really excited to be able to demonstrate it this way. Now, this setup has grown immensely, even since you last saw it. I'm now booted off a hard drive, and there's a couple of other things here, but I just wanted to cover very quickly that I will be using this digitizer, which is a 9111 HP digitizer that actually speaks HPGL itself. That's how it works. There's also the 7470 here. This is where I usually leave it. And that one is the one that is permanently attached to the system at plotter address 5, which is the normal plotter address. So changing the 7475 to address 7 works out better for me because this one's actually address 6. So we'll be using address 7 with 7475. Doesn't really matter, but you can see how you can have all of these different peripherals connected, and you just have to change the address so that you know where they're at. Kind of like SCSI. From here though, I'm going to point the camera that you're looking at me through directly at the monitor because there really isn't a good way of doing video capture of this, I've determined, and I need a dedicated camera for that. A side note about something that I've learned since I got this system, I was originally concerned that my monitor was very dim, but it turns out these monitors are very dim. I finally found a figure somewhere in one of the manuals. I couldn't find it again before recording, but this monitor is apparently 15 foot Lamberts, which comes out to about 50 nits as its official rating for how bright it is, which is ridiculously dim. And to put this another way, in one of the manuals, it talks about photographing the screen and what camera settings HP themselves used to do this. They used 64 ISO film with a 1 second exposure, if I remember correctly. So it's just a very dim monitor to begin with. So if you see my hand waving in front of it and glowing, it's because I adjusted it to be a little bit brighter so you can actually see it in the video. And there we go. I also let it warm up for about a half an hour before I started filming, which I've found can help quite a bit too. This thing's just weird. Anyway, this is the program that I have written, and this is actually an evolution of the same program that I used to demonstrate the 9111, but it's gotten a lot bigger and the scope has changed quite a bit. But I don't really want to go over the entire thing here, so we're just going to hit some key points, and I'm going to actually do that by closing this out and just running it. So, to start with here, I now have the ability to see where I'm going to draw, and I can go ahead and place lines down, and if I switch to moving, I'll get a point that tells me where I last moved to, and then I can continue my lines from here. And where this program really becomes good now for demonstrating the 7475 is that I've added color changing, so I can now change between 7 or 8 different colors, I can't remember, it's probably 8, on here to demonstrate the ridiculous color capability of this machine. Now to make these next few demos work a little better, I've changed out the pen colors in the 7475 to match the default pen colors that the Series 200 computer uses here. I've shown in the past that this thing can change the palette colors, so you can have them be set to anything you want, but having it be set to a wide variety like this, I like a little more. So I've matched that as best I can over at the pens that I've got in it. All right, I've reset the drawing here, and the other big change with this program from the last one is the fact that it actually has the ability to recall all of the data and redisplay it because it is storing all of the lines in an array, which means I can also plot the data. So let's go ahead and draw something really simple and quick here, and I'll show you what this looks like. Oh yeah, this version of the program also supports freehand drawing now. And there we are, one very terrible rendition of the Tech Tangents logo. So let's go ahead and attempt to plot this now. Oh, I messed up and left a line on there. Whoops. Also, you can probably hear a slight fault that this thing has. One of the servo motors is buzzing because it is using current to hold the pen in position. It was kind of stuck between a couple of the step points. So that's a thing that this just does every now and then, and one of the reviews I looked at even actually mentioned that it can be super noisy even when sitting there doing nothing. So I can totally continue and do more stuff here. You know what's funny is I could actually take this, start down here. Now let's start over here, about right there. Those points that it just put, it will actually store all of those moves. But we'll start down there, and then I'm gonna go ahead and just sign the plot. Why not? So, oh no, I just put a bunch of moves in. Whoops. Okay, let's sign it here. Oh, I forget how you do B's. There we go. All right. There's my horrible signature. I will say, I think I've noticed trying to do some freehand drawing stuff that this digitizer has some like dead points for the pen or something. I'm not 100% sure. Maybe just doesn't do high throughput. But yeah, it gets a little wobbly in some places. But I can now add that signature to the existing plot, and we're gonna go ahead and do that in black. So let's see it do this. And there we are. I have forged my own signature using it. Oh, man. Well, I am enjoying making progress on my own software here, but there are some much better demonstrations of the plotter if we go ahead and utilize some of the example discs and software that came with this machine. So I'm gonna go ahead and load in one of these. It is a fairly iconic HP plotter image, and we will plot that out on here. Yeah, this thing's pretty darn awesome. Well, that is the 7475 plotter from HP. That thing rocks. I can totally see why it just became the de facto standard and was very hard to usurp. I mean, sure, could be faster, but you start running into physical limitations of pens then. There's probably only so fast you can go and still get the ink out of it in time. So I wouldn't be surprised if this thing is about as fast as you want to go already, which means that really, aside from adding more colors that you can hold, there's not a lot else to gain from improving upon this. And I'm guessing that not many companies could improve upon it, which is why this thing had such a long run. But that's all I have to say about it. I am going to give you one more plot though. You may have noticed the sticker on top. That actually tells you how to run a demo using the plotter by holding two buttons when you turn it on. So I'm going to go ahead and let the video end with that, running at normal speed, so you can get all the plotter action that you want. But that's it for now. So I hope you guys enjoyed this look at the HP 7475, and if you want to see other HP hardware in the future, I'm clearly invested in it, and I definitely have some really cool stuff coming up soon, so you may want to subscribe. If you want to help support the channel, you can get a shirt like this one, or find me on Patreon, but for now, that's it, and I will see you next time.